Hi. So in this video we're going to be looking at the trigonometric ratios. Okay, so trigonometric ratios, and more specifically at the application in right angle triangles. Right angled triangles. So we see that you have a right angle triangle, as I've showed you in the previous videos. Okay, a right angle triangle just means that we have a right angle, okay, and this angle is 90 degrees. So this is your right angle, okay, your right angle. Okay, so looking at this triangle, right, you have to have an angle inside, right? So it can be an angle in here, okay, let's call this one alpha, or it can be an angle in here that we can call theta. So obviously alpha is the A, if I write it here for you guys. So alpha and theta, these are angles measured in degrees or radians, whichever you prefer. Okay. All right. Okay. So if we have to look at this angle theta and we have to label this triangle, okay. So we've got sides, okay. We've got sides, okay. So these are the angles. And if we had to look at the corresponding sides, okay, that's an important word, corresponding sides, okay. So the corresponding side to this, right, the one that's corresponding to it is usually called the opposite. It's called the opposite side, all right. And then we have the side that's opposite to the 90. So if you look at the side opposite to the 90, okay, that's usually called your hypotenuse. All right, and then obviously you've got one remaining side that's remaining, and that side is called the adjacent. It's called the adjacent side. All right, adjacent. Okay, so looking at it now, okay, we've seen that you've got three different side lengths. The one is called the opposite, the one is called the adjacent, and the one is called the hypotenuse. Now it's very important to take note of how to draw these things in. Okay, so the adjacent, I started off by first understanding which angle I'm dealing with. So if I'm dealing with this angle here, which is, we said it was theta, then the side opposite to the angle is called opposite. Then we went to the side opposite of the right angle, and that's called the hypotenuse. And then the remaining side is called the adjacent. Okay, so if we look at the three trigonometric ratios, okay, the first one that we have, okay, the primary ones, the first one that we have, we said was sine. Okay, so the sine ratio stands for the length of the opposite, okay, divided by the length of the hypotenuse. All right, that's what the sine ratio stands for. Okay, and then the cosine ratio is your adjacent. It's your adjacent length divided by your hypotenuse length. Okay, and then you have your tan of your angle, which is your opposite length divided by your adjacent length. Okay, so just to take note here, these are lengths. Okay, these are side lengths. Okay, those are side lengths. All right, and they are measured in, as we said, inches, meters, feet, whatever, millimeters, whatever unit of distance you have. Okay, even this is a length as well in terms of the triangle. Okay, then in terms of angles, the theta would be your angle. Okay, so this is your angle. So you've got the side lengths and you've got the angle. So you can see that tan of the angle, cos of the angle, sine of the angle is equal to the ratio of the side lengths. Okay, these are the three primary ones, okay, three primary trigonometric ratios. There are three more, which are the inverses of these, which I will explain in the next slide. Just another thing to note here, let's color code this for easy reading. So the opposite side, we had it in green, okay, that would be the opposite side, and then obviously the adjacent would be in blue, okay, so that's the adjacent there, alright, and then our hypotenuse be red, okay. Alright, so it's just a simple matter of actually finding the side lengths, okay, and the angles, okay. So now if we just look at a way of memorizing this, we have a saying that's called SOHCAHTOA, okay. So SOHCAHTOA basically stands for sine, which is equal to opposite over adjacent, opposite over hypotenuse, and we have cos, which is adjacent over hypotenuse, then we have tan, which is opposite over adjacent. Okay, so we've got three here: sine, which is opposite over hypotenuse, cosine, which is adjacent over hypotenuse, and tangent, which is opposite over adjacent. All right, so that's an easy way of trying to memorize the trigonometric ratios. Okay, just an additional note here, just pay careful attention to the fact that these are lengths, the opposite side and the hypotenuse and the adjacent and all of these things, these are lengths, okay? You must be careful to note that these are definitely lengths. All right, these are lengths. Yeah, there we go, they're lengths. Okay, so if we move on here to how we can use these trigonometric ratios, that will follow in the next video.